Welcome friends. So today we are meeting a new technology called as Elastic. So hi, I am Prasad and we have Samir with us. And Samir is going to introduce us to this new exciting technology, Elastic. So Samir, before going into the details of this technology, can you just share with our viewers what are the typical challenges are there in an enterprise for searching data and doing analytics of that data?
Yeah, sure. Yeah. I think whether it's enterprise or internet-based applications, right? Public, applications. I think as applications started becoming they had to handle a big data kind of requirements, and this happened, even 7-8 years back or even before that, right? And your typical applications, you can always start with e-commerce, a lot of traffic coming in and a lot of searching of information happening. So if you have a very large e-commerce site, which requires a lot of textual searching, that's one example. Or you have other type of enterprise applications, a lot of logs coming in for log analytics, and you want to make it, some intelligence out of it, do some security analysis out of it, or other kind of applications like a lot of events, streaming in, a lot of metrics data coming in, and you're doing observability and raising alarms. So these kind of applications, these are really big data applications. They started facing challenges if they adhere to a traditional RDBMS model of storage and searching. Okay, RDBMS has inherent limitations when it comes to this kind of requirements. So searching and querying of data, and here the data is not just traditional relational data, right? It's a textual data or it's a non-relational data. On that, searching querying is non-performant on RDBMS. Everybody knows that because your data is fundamentally heterogeneous. It has JSONs, it has documents, pictures, and a lot of text. Okay, number one. Number two, we are talking about searching and analytics, right? So out of that data, now we want to do call out information and do data aggregations and build intelligence so that reporting becomes easier, right? So even the reporting queries against these kind of traditional relation structures are not performant. And you have to put something else, data processing, data marts, OLAP, and all that. So right, but that is not real time. Whereas today's applications, which have big data streaming kind of applications, they have requirements of doing searching, querying, analytics in a near real-time requirement. That's where we have a problem, right? And a way to solve that was, like I said, putting these additional layer and additional technologies. And scaling was also challenged, right, in this kind of application, because traditional database require, I think we have seen that, right? 32 GB, 32 CPU, 64 GB. Then you upgrade it to 64 CPU, 128 GB, all that. So it's a vertical scaling. You can't scale horizontally, actually. So this overall became a problem, and this overall is still a problem.
Yeah. So in a nutshell, I think the challenge is if I'm running a very large application, maybe an enterprise or whether an internet driven. So probably I will like to have some kind of a searching capability similar to what typically a Google search may provide.
Absolutely.
So it can search through my entire data, documents, PDF files and whatnot, which is there. So through unstructured data, and maybe there is a requirement of doing some analytics on the top of that. Exactly. So maybe what is trending. So maybe if it is an e-commerce kind of a catalog, so which category is where maximum interest is shown, what kind of products,
most
and that should come from likes, and or maybe if there are any issues, then which one is really trending. So I think if one has to implement all those kind of capabilities, then we have a challenge. I think that's where probably these challenges are summing up. I think that's what I have.
Very true. Absolutely.
Okay. Yeah. Great. So what is the solution for that? So how we can leverage technology to address these challenges?
Right. So I think a ground up thinking was needed, and these challenges were felt when big data kind of things started 10 years back, right? And this is where a good story about Shea Bannon, right? He came up with an idea of using underlying Apache Lucene search engine instead of RDBMS to solve some of these problems, and it was basically to help his wife and all that. Interesting story which you can find on net. And so by around 2009, 2010, he came up with Elasticsearch because he thought a very different approach is needed so that searching becomes effective and your storage is tuned for searching, essentially, right? So that is the approach he took. And that is what led to emergence of Elasticsearch essentially.
Elasticsearch.
Yeah.
So internally, this Elasticsearch is using this Lucene, Apache Lucene technology.
Apache Lucene technology. Unlike traditional RDBMS approach, whether it's Oracle, SQL Server, Postgres, which use a traditional relational approach, here it is a search engine driven approach of looking at data.
Kind of Okay. So how it really works, like how it helps in doing searching and analytics of data?
Yeah, right. Yeah, so basically, because this is meant to be a search and analytics engine, and it is also meant to handle a lot of variety of data, structured and non-structured, like you said, right? And so your data could consist of text, numbers, geospatial, time series, and whatnot, right? So this is where the approach was, as the data comes in, when you want to search on words, you want to search on some of the analytic information, like which are the top things and all that, right? So on top of the indexing architecture, which Lucene has, Elasticsearch introduced concepts of mappers, analyzers, tokenizers, etc. So what that means is, instead of a traditional RDBMS approach of defining a very static schema upfront, what it does is your schemas are a little bit flexible. So you have two approaches. You can be completely flexible, which means dynamic. So you let Elasticsearch decide, analyze incoming data and figure out, oh, this is number, oh, this is a date, oh, this seems to be text, things like that. Or you can give, of course, you can obviously give, in a JSON ways, you can map your data yourself also. So you have both you have flexibility around there. So that's step number one. And then what you want to do is, this data, and typically you are talking about textuals and whatnot, right? Now you need to pass the data, or you need to analyze the data. So standard analysis techniques, like you want to remove unwanted words or unwanted characters which don't make sense when you're searching, etc. Right? Not just that, a typical search engine way of doing it, which means if I type a word, I say, I have done something, or I did something, right? So done, did. So I need synonyms, or I need synonyms for the word run, ran, fast, faster, and things like that. So even that ingestion has to happen. It does that. And then finally, my text, which is a sentence, which is a bunch of words, tokenizing them, breaking them into words. That's a simple step. But taking a word, a bigger word, and breaking it up so that when I type a few characters here and there, I should be able to search. So tokenization, that's the tokenization. So all this is done, and this is given kind of free to you. There are built-in ones, you can build custom ones. And this is what it does. This aids searching, basically.
Yeah. So basically, like all my data which is there, like whether it's a large text file, it will sort of parse it and then generate indexes using that, so that my search will become okay. Correct. So all that heavy lifting is done by the search technology, like Elastic.
Right. Okay. Yeah, and to aid further into the further analytics, now that you have generated these tokens, now you can do many things around it, because if the token is a number, then you can do computation of metrics, average, max, and you can just define it very simply using JSON, and it will do that generation, and it will keep that readily generated for you. So that these aggregations, whether it's simple metrics or taking a bunch of tokens and a bunch of data and bucketizing them, categorizing them, so that you can generate histograms saying 10 of these happened or 10 of these products exist or whatever it is, right? You can do that. So that aggregation power is there, and that power then can be leveraged through APIs by analytics UI technologies like Kibana, because Elastic is part of a ELKStack, right? K stands for Kibana, which is for reporting. Of course, we are not going there, but it is important that all this is done readily, so that external engines can make API-based queries and readily utilize the aggregations, which makes analytics easier. This is what it does.
Okay. Yeah. So typically, is it like, let's say a particular word or particular term is getting mentioned many times, then probably we'll be able to figure it out, like, this is like trending, and those kind of features can be
absolutely heat maps that we generate, or word maps and all that, right? All this can be readily generated, because all readily generated. You can define very easily. You can define using JSON, and all this aggregated data also will be stored separately in real time, in near real time, I would say, basically.
Okay.
Yeah. So that's a great power. You don't need a data warehouse, ETL, data warehouse, OLAP, all these things, basically, which can do once a day they will process it. None of that thing is needed. Just near real time. Right.
So you just pump the data, and then it will run its algorithms, and then make it available to you. Okay. Great. But then if you have so much amount of data and so many documents, and in fact heterogeneous document, like how it ensures that my search is fast? Because I'm
Right.
sure then it's complex thing, isn't it? Like a lot of
This is
indexes
complex.
and all that.
Yeah, if we are thinking about it as a database and blobs and whatnot, then this is definitely complex, right? But because first of all, your power of parsing the information and dividing it, and then when it comes to the storage, the approach is not necessarily a relational database-based approach. I would say it is more like if you have thought about or you have seen Hadoop systems and MapReduce, right? I think some of those philosophies are picked up. So at the core, you have using search engine. Search engine creates indexes, and these indexes are then these are very different kind of indexes. Unlike the bitter indexes in database, right? These are inverted indexes where all the information from your text, which is important information meant for searching, that is pulled out and that is indexed, and they all point to your final record. That helps you search faster. So it is tuned for searching like that, tuned for searching for textual or tuned for searching for aggregated information. Even your aggregated information is stored in these kind of indexes, right? And it basically ensures that it is meant for read or search, but your writes are slowed down a little bit. So your writes are actually delayed. So you could have millions of records coming in, pouring in, right? But this is not transactional system, right? So it basically your record writing, the way you do a ACID transaction database, is not followed here. You send it for writing, right? May happen a second or two later, and things like that. That's one difference. So that basically it ensures that Elasticsearch server is not kind of now too busy doing lockings and whatnot.
Doing
right?
the lockings and
exactly. So just focus on that search and extracting, culling out information for search. That is what it focuses on.
Yeah. So this inverted index which you mentioned, so what it does, it just generates every possible combination, or how it does from text? Like
correct. I mean, it can generate every possible combination, and you can tune it, saying that break a word, but how do you want to break it? Large word, just 3 characters, then you'll have too many combination, or 5 or 7 characters, then maybe you have less combination. It's up to you. But yes, if you tell it 3 character is my limit, then it will generate all possible 3 characters of a word and generate show that in the index. Your index will be much bigger probably than your data, but then all your searches, e-commerce searches and things like that will be ultra fast basically.
Ultra fast. Yeah, I was going to say that, like, if it is generating so many things, then index is definitely going to get bigger.
Index is something to watch out for. Yes.
To watch out for. Absolutely. Great. So that's how I think it is searching very fast. But then when we have lots of data or many documents, like how it takes care of the scalability of the application.
Correct. And
is there any? Do we need a large server, or how it does?
Yeah. So large server is a traditional approach, right? And we were used to that. Like as a database administrator, I own a huge server, but here you are again becoming a little bit more like a cloud, right? So you're looking at putting together a bunch of machines together in a cluster and node format, right? So it follows the cluster node architecture format. So your data is in indexes. Indexes are spread across the nodes, multiple nodes, and each node need not be a 64 CPU machine, right? It could be a 4 CPU machine, but you can put together 20 of those and you get the power. So that's the basic funda. And so that way your data is actually distributed across machines, which means your querying is also intelligent, just like MapReduce, right? You're querying across them and putting it together. So there is a parallelization, which also helps finally, but you also get a scalability. That's how it works. So this is a very interesting thing, the whole thing that we talked about, and there are more details to it. Obviously, it's an in-depth topic, and I think we have a video coming in, and one must look at that to understand in depth.
Yeah, perfect. So, Samir, can you just quickly summarize in literally 1 minute or 2 minutes? Okay, what it is, and just for the benefit of as a takeaway for our viewers.
Right. So Elasticsearch.
Probably you have done that already. Just very quick summary.
Yeah. So think of Elasticsearch as your fast search and analytics engine, right? Which is distributed. But good thing is it's free and it's open sourced. So you can just use it. You can put together smaller machines together to leverage the power of that. And it is tuned to handle heterogeneous data, textual, numeric, all that structured, unstructured, all that, right? So the real strength of Elasticsearch is index, store, search, and analyze. And that's where it's really suitable. That's what we can say.
Yeah, I think that's a perfect summary of this technology. So friends, this is how Elastic can help us. And as Samir has already mentioned, we have one more video coming up where if you are more interested into this particular technology, then you will be able to learn it in little bit more detail from an Elastic expert.
Yeah, I
So-
think there is so much to Elastic that we just can't cover
Yeah,
in this short video.
cover it.
So
Absolutely,
do watch that
absolutely.
in-depth video by Mr. Amit Svedar.
Yeah. Okay, fine. Perfect. So thanks, Samir, for introducing this new technology. And thanks, viewers, for watching this video. And if you liked it, please forward to your friends, colleagues, and please subscribe to our channel. Thank you. Thank
Keep
you very
watching
much.
and keep watching. Thank you.
Watching.
Yeah.
Thank you.
Thank
Bye.
you. Bye.